Example 1 has to do with the far right and far left behavior of the graph of a polynomial function with leading term a sub n x to the n. Okay, let me just demystify this first of all. Some number times x to some power. The leading term is the highest power term in the polynomial. So if you have some polynomial p of x, let's say that is 7x plus 3 plus 5x to the third minus 2x squared. It's not descending order, but it's got 4 terms in this case. The leading term is the term with the highest power. It's not the term in the front of the polynomial. So 5x cubed is the leading term. So a sub n 5, x to the n, x cubed. So we have a number and we have a power. And those two things are going to establish the far right and far left behavior. What that means is I go far left going towards x equals negative infinity, what's going to happen to the graph? As I go to the far right towards positive infinity, what's going to happen to the graph? And the choices with polynomial functions are either going to go straight up or straight down, basically. All right, so the two scenarios for the a sub n, the number in front of x, is that a sub n is either positive or negative. If it's 0, then the leading term is that one, and you go to the next lower power. So it's going to be either positive or negative. So if it's positive and n is even, it'll be up to both left and right. And if a is negative and n is even, it'll be down to the left and the right. So again, if it's even power, left and right are the same. Positive up, up, negative down, down. All right. If n is odd, which is the case here, normal is what the positive one is. Normally, as you get bigger negative x, you get bigger negative y. As you get bigger positive x, you get bigger positive y. So down to the left, up to the right would be normal. If a is negative, or if the number in front of x cubed, the highest power term is negative, it'll go, as you get bigger x negative, it goes up, bigger x positive goes down. So basically that's what you're looking at every time. When you're asked to determine the end behavior, the highest power term has the only effects on the end behavior. As x goes to infinity, x cubed is so much bigger than x squared has no purpose anymore. So only the highest power term counts. So looking at this problem, examine the leading term and determine the far left and far right behavior of the graph of each polynomial function. So for function a, p of x equals x cubed minus x, we have x cubed. Okay? What I want you to get out of that leading term is what a sub n is, which is positive 1, and determine its characteristic that matters to us. Positive 1 is positive, greater than 0. All right? And the other thing I care about is what n equals, which is 3, which is odd. Okay, so I want you to glean the characteristics off these two numbers that matter to us. Leading term matters, coefficient of 1, power of 3. The coefficient's positive, the power is odd. Going back to my chart, I've got a positive a sub n. I've got an odd power, that's down left, up right. So left, down, right, up. So this is showing work right here, and this is giving me the answer. That's what I'm expecting on these problems where it says, give me the end behavior. Okay, what's the lead term on s of x? 1/2 x to the fourth, right? There's my leading term. So 1/2 x to the fourth. So a sub n is equal to 1/2, which is greater than 0. And n is equal to 4, which is even. 4 is even, all right? So we have an even power, which means either up, up, or down, down. A positive a sub n is the up, up. So left, up, right, up. I'm not determining anything else except for as I go way off to the left and right, the graph's going up. What happens in between might do weird stuff, but going left and right, way far left, up, way far right, up. Next one. Lead term is?
Negative 2x to the third.
Very good. Negative 2x to the cube. X cubed. And negative 2x cubed, so a sub n this time is equal to negative 2, which is less than 0, and n is equal to 3, which is odd. And again, this is what normally happens for an odd power up here in red. Normally, if the a sub n is positive, go big negative, it goes big negative, go big positive, goes big positive. When a sub n is negative, it switches the normal. So left and right, as x gets extremely large negative, the function is going to go up. As x gets extremely large positive, the function is going to go down. And again, if you just imagine y, if x is really big negative, this is going to be a really big negative number, right? Multiplied by a negative, now it's a really big positive number. So as x gets really huge, the graph's increasing in size. If x is a really big positive number, this is really big positive, the negative makes it negative, so as you go really big positive, the graph's going to go down. All right? So once again, there's my work, there's my answer. Finally, the last one. Lead term is?
Negative x to the fourth.
Negative x to the fourth. Again, every single time, always find the highest power term, that's the one that matters, nothing else. When we're dealing with n behavior matters except the highest power term. A sub n in this case is equal to negative 1. Remember, no coefficient means 1. Negative 1 is less than 0. We can see very clearly n is equal to 4, which is even. Even means the same, either up, up, or down, down. The negative a sub n means that as x gets really big, we raise it to the fourth power, now it's a positive number. The minus makes it go negative, so we go down, down. So left, down,